Okay, so this is topic 10, Introduction to System of Linear Equations. So we're going to talk about the types of solutions you can have, and we're going to be finding the solutions by graphing. So there are three types of solutions that we can have when we are dealing with the system of linear equations. You can have one solution. So if you look here, that's when our two lines cross each other one time. So there's one solution, and that solution is always where they cross, so right here. You can have no solution. That means no matter how far these lines go out, they will never cross. No solution graphs are always lines that are parallel. Okay, so if they have the same slope, they're parallel, and if they're parallel, that means they will have no solution. Okay, and then the last one is infinite solutions. So that means that the two lines are actually scalars of each other. So when you draw them, they're going to look like they're on top of each other. So it just looks like one line. But this is actually two lines on top of each other. Okay. So we're going to take the skills that we learned to graph, so plotting the y-intercept and doing that rise over run, and then once we have the two lines graphed, we're going to determine if it has one solution, and if it does, we have to name the point, no solutions, or infinitely many solutions. Okay, so this is number one. So first, before we can start graphing this, we have to make sure these lines are in that slope-intercept form, so that y equals mx plus b. Are both these lines good on number one?
Yes.
Yes. So then we find the y-intercept of both. So what would be the y-intercept of the first equation?
2 over 3.
Y-intercept. This equation. -3, and how do we write that as a point? 0, -3. Remember that y-intercept in that y equals mx plus b is that b value, so the value that's at the end. Okay, what would be our slope for the first equation? Good, 2 over 1, and we're writing it as 2 over 1 because we are doing that rise over run. What about the y-intercept for the next equation? Good, 2, and we would write that as a point, 0, 2. And what about the slope? -3 over 1. So now that we have the information we need from both equations, we're going to now graph. So I'm going to plot the point 0, -3. And my slope, 2 over 1, is telling me to go up 2. Which way 1? To the left or to the right? The right, because it's positive, right? So positive to the right, so right here. Okay, so that looks like my first line is right here. Okay, then I look at my information for the second line, so I plot that 0, 2. And this -3 over 1 is telling me to go which direction? Up 3 or down 3? Down 3. And then right 1. Notice right there that they share that point. So that's going to be what type of solution? One solution at what point? We're looking right here where they cross. What point is that? -1, -1. So that's our answer. When we have one solution, your answer is always the solution, the point. Okay, you couldn't just write one solution and then go to the next problem. I have to know the point. Okay. Now looking at number 2, are both our equation in that y equals mx plus b format? Yes or no? Yes, they're both in that slope-intercept format. So looking at the equation I highlighted in green, what would be the y-intercept? 1, so 0, 1. And what about the slope? -5/3. Always the number in front of x. So for the other equation, what would be the y-intercept? Yep, 0, -3. We always write it as a point. And then what would be the slope? -1/3. Okay, so I got both my information. Now I'm going to go plot. So I have 0, 1. And that -5/3 is telling me to do what? Down 5, right 3. Yep. 1, 2, 3, 4, 5. 1, 2, 3. So that's my first equation. And then I plot my other y-intercept, which was at -3. And what is that -1/3 slope telling me to do? Good, so down 1, right 3. And notice it's going to also cross at that same point. So right here. And pretend that's straight.
It's a straight line, 5 signal.
Yeah. So that means right there is our solution. And what point is that? Good, 3, -4. So it's a 1 solution at 3, -4. Okay, and again, there's several methods to solve system of linear equations. Today we are just looking at how to solve them by graphing. Okay.
You said that was a 1 point, right?
Yeah, 1 solution. Anytime it crosses and intersects, it's always 1 solution. Okay, so let's look now at number 3. So this first equation, what would be our y-intercept? 0, 1. And what's our slope?
1/1.
Close.
1.
-1/1 because of that negative in front of the x. Good. And then for this other equation, x equals 3, we are going to have which type of line? A vertical or horizontal line?
Vertical. No, horizontal, sorry.
No, vertical.
Vertical,
Yeah. We're going to have a vertical line at 3, 0 because this is x equals 3. If it said y equals 3, then it would be a horizontal line. Okay. So in this second equation, we weren't able to get our normal information of a y-intercept and a slope. We just know that if equation only has x equal to a number, we're going to have a vertical line at that number. Okay, so plotting my 0, 1. This -1/1 slope is telling me to do what? Good. So that's my first one. Okay, and then I draw my vertical line at when x is 3, so right here. Okay, so I can't really tell exactly where that point is, so I can just continue my rise over run of that -1/1 down until I meet that pink line. So that would be right here. So this is where it's crossing. And you could do that in either direction too to make your line as straight as possible. So that means it crosses right here at 1 solution. And what's that solution?
3, -2.
3, -2. So 1 solution at 3, -2. Okay, go ahead and take a moment and try 4. Remember to get your information first. then graph. Okay, I'm going to go ahead and start writing the information. You still continue working. For the first equation, you should have got the y-intercept of 0, 1 with a slope of 4 over 1. And then for the second equation, a y-intercept of 0, -2 and a slope of 1 over 1. So I'm going to go ahead and start plotting those. Okay, so both your lines should look like this, and you should have got the solution right here at -2, -4. Does that sound right? Maybe not. Let me look. 1, 2, 3, 4. I think my green line's a little off. Yeah. When you're graphing, it is important to make sure you're, like if you're going to the slope in one direction, to also check it in the other direction so you don't do the mistake that I just did. Because this is actually going through that point. This is going through this point. So then you should have got -1, -3. Does that sound about right to everybody? -1, -3, yeah. So remember your slope, for example, that 4 over 1, you could also write that as -4 over -1, right? Because a negative divided by a negative is still a positive. So the 4 over 1 is going in one direction, and that -4 over -1 is going in the opposite direction. So that's how you're able to get a more accurate line. Okay, this is to go in the other direction. Just change both signs. Okay. Okay, let's look at number 5. So on number 5, again, both of my equations are in that y equals mx plus b format. So I'm going to find my y-intercept for both. So my y-intercept for the first one is what number? 0, 2. What about for the second one? Good. And the slope for the first one? And the slope for the second one? 2 over 1, and we write it over 1 because we're graphing. Okay, so graphing that 0, 2, and then doing my slope -1 over 3, so down 1, right 3. I'm going to do the opposite too. I'm going to go up 1, left 3. And then for my second equation, I have 0, negative 3 as my y-intercept. And I'm going to go up to right 1. And I'm going to go up to right 1 again. So it hits right here. Okay, so this looks like one solution at what point? Yep, 2, 1. So one solution, 2, 1. Most problems that you will see with this will most likely have one solution, okay? It is less common to have no solution or infinite solution. Okay. Okay, let's go ahead and look at number 6. So right here, looking at both equations, what is our y-intercept for the first one? 0, 3. What about the slope?
Negative 1 over 4.
Good. Y-intercept for the second one? 0, negative 2. And then the slope?
Negative 3 over 2.
Negative 3 over 2. And then we start plotting that information. So the first one, 0, 3, and I'm going to go down 1, right 4. And then at 0, negative 2, I'm going to go down 3, right 2. And I'm going to go in the opposite direction too. So up 3, left 2, up 3, left 2. Because I want to see where I hit that other line exactly. Okay. So that means I have one solution at what point? Good, negative 4, 4. Any questions so far? This is also just practicing our graphing skills that we learned in previous notes. Okay, number 7, we're going to see that second equation, which is going to look like what type of line? Horizontal. Good. So horizontal. At what point?
0, 1.
0, 1. Good, because we're dealing with the y's, so my point has to have a y value there. So 0, 1. And then we know our y-intercept is 0, negative 3 for the first equation, and our slope is 4 over 3. So graphing my first one, I have 0, negative 3. And then I have my slope of up 4, right 3. Okay. And I know that my next point at 0, 1 is just going to be a horizontal line. So that shows me that I have one solution at what point?
3, 1.
3, 1. Okay. Okay, on the next equation, again, they're both in that y equals mx plus b format. They won't always be. We'll have examples further along where we're going to have to change the format. So again, we know that the y-intercept for the first equation is what number? 0, -4, and our slope is -2/1. And then our y-intercept for the second one, 0, 2, and our slope, 4/1. Okay, so plotting that information, I have 0, -4. And then, if you notice here, it says to go down 2, right 1. But if I go down 2, I'm off the graph. So this is where it would be good to do the opposite. So instead of down 2, right 1, I'm going to go up 2, left 1. Up 2, left 1. Okay, and then my next y-intercept at 0, 2. This is telling me to go up 4, right 1. But again, the same thing happens. If I go up 4, I'm off the graph. So then I do the opposite. I go down 4, left 1. So right here. So it's going to share that point. So it shares that point right here. So that tells us this is one solution at what point?
1,
-1, -2. Okay, so how are you guys feeling about this so far? Pretty easy? Okay. We're going to go ahead and skip 9 and 10. So that's more of the same. And we're going to go to 11 and 12. Okay. So what's the difference from 11, 12 from the rest of the problems we were doing? Good, they're in standard form. So in order to plot these, we need to put them in the slope-intercept form. So that will be our first step. Okay, so looking at the first equation, and let me see, let me write it down here. So I have that 5x plus y is equal to 4. In order to put this in y equals mx plus b form, I need to get y by itself. So what am I doing? Good, subtract 5x over, and I get y is equal to -5x plus 4. Remember, whatever is attached to your x goes first because we're trying to put it in the form y equals mx plus b. So looking at this equation, which is now our new green equation, what is the y-intercept here? 0, 4, and what's our slope? Okay, I'm going to go ahead and plot that first. So 0, 4, and then -5/1. So down 5, 1, 2, 3, 4, 5, right 1. And that is my line for the first one. Okay. Let's see. The second one, I have that x minus y equals 2. So in order to get y by itself, what do I need to do? Subtract x, and I'm left with -y equals -x plus 2. I can't have that negative there, so what do I need to do to the entire equation?
Divided by -1.
Divide by -1. So dividing everything by -1. And all that does is changes the sign. So we have y equals +x minus 2. And that is now our new pink equation. So our y-intercept for that one is going to be what? 0, -2. And what's my slope? 1/1. So I'm plotting that 0, -2. And I'm going to go up 1, right 1. And then we notice right here it shares that point. So we know this is one solution at what point? 1, -1. That's our answer. So on these ones, we have that extra step of turning standard form into slope-intercept form. Okay. So we're going to do the same with 12. So starting with the first equation, x minus 4y equals -4. What do I need to do first to get y by itself?
Divide by -4? Oh.
Not yet.
Subtract x.
Subtract x. So I have -4y equals -x minus 4. Now I can divide by that -4. And I'm left with y is equal to 1/4 x, because remember there is that invisible 1 in front of x. So I had -1 over -4, which is positive 1/4, and then plus 1. Okay.
How does that work? The negative x over -4 becomes positive.
There's just a rule that says negative divided by negative is positive.
Okay.
Just like there's negative times negative is positive. It's just a rule you need to memorize for that one. Okay, and then we have our other equation, 5x minus 4y is equal to 12. What would we do first to get y by itself? Good, so subtract 5x. So we get -4y is equal to -5x plus 12. And then what?
Divide by -4.
So we have y is equal to what? What number is in front of x? 5/4, because the negatives cancel. And then 12 divided by -4 is -3. So that's our other equation. Okay. Now that we have both these equations, let's go ahead and plot the green one first. So we know that the y-intercept is what? 0, 1. So I'm going to plot that point. And then my slope is telling me to do what?
Up 1, right 4.
Up 1, right 4. I'm also going to go down 1, left 4. Okay. And then for the pink equation, what is that y-intercept?
0,
Yep, 0, -3. And then what is the slope telling me to do here?
up 5, right 4.
Up 5. So 1, 2, 3, 4, 5. Right 4. 1, 2, 3, 4. So it shares this point right here. Okay, which means this has the solution of, good, 4, 2. Okay, let's look at 13, 14. Okay, so again, these equations are not in y equals mx plus b form, so we need to place them in that form. Okay, so looking at my first equation, that x plus y equals 3, what's my first step to get y by itself?
Subtract x.
Subtract x. So I get y equals -x plus 3. Okay, so that's my new green. And then I have 8x plus y equals -4. What's my step to get y by itself?
Subtract
subtract 8x, yep. We're always moving the x's first, and then if there's ever a number in front of y is when we divide everything. So we have y is equal to negative 8x minus 4, and that's the new pink equation. So now that we have them both in that y equals mx plus b form, we're going to go ahead and graph. So from the first equation, what is our y-intercept?
0,3.
0, 3. Good. So I'm going to plot that point. And my slope is telling me to do what?
Down 1 over 1.
Good. Down 1 over 1 because of that negative in front of the x. So down 1, right 1. And I'm just going to keep doing that down the graph. And then for my other equation, what is my y-intercept? Good, 0, negative 4, so it's down here. And my slope is telling me to do what?
Down 8 over 1.
Good. Am I able to go down 8? No, so which direction should I go instead? Up 8, and then which way 1? Left 1. So 1, 2, 3, 4, 5, 6, 7, 8, and then 1. So right up here. Okay, so this means this has one solution at what point? Negative 1, comma 4. Okay, and when you see these type of equations, problems on the test, I expect to see all this work, especially if your equations are in standard form. I need to see you put them into y-intercept form. Okay, on number 14, what do we notice about that second equation?
It's just a vertical line.
Good, it's going to be a vertical line at what point? Negative 2, 0, because we have x equals a number, meaning that number has to be in the x value. So negative 2, comma 0. That other equation is in standard form, so we're going to have to get it out of that. So that x minus y equals 2, what do we do first? Subtract x. We get negative y is equal to negative x plus 2. And then we don't want that negative in the front, so what are we going to do to all the signs?
Divide by negative 1.
Good, divide by negative 1, and what that does is it changes all the signs. So now I have y equals x minus 2. Notice the only thing I did differently was change the signs. And that's the same as dividing everything by negative 1. Okay. So for this equation here, that y equals x minus 2, what is the y-intercept? 0, negative 2. And what is that slope telling me to do?
Up 1 over 1.
Good. Up 1, right 1. Now I'm going to do that a couple times. And that is this equation. And then for the other one, we know we just look at the point negative 2, 0. So right here, and we draw a vertical line. So that shows us we have one solution at this point, which is
Negative 2, comma negative 4.
negative 2, negative 4. Okay. Yes.
So if we some equations like this, if you were given knowledge that the lines would cross, they would have to cross the vertical lines x point, or else it would be
Correct.
their solution.
Well, for problems like 14, since we have that vertical line at -2, you know that your answer where it crosses has to be, yes, -2 in the x values and then whatever number in the y values. For these ones, since we didn't see same slope and stuff like that, we know it's going to always be one solution. The only way it would be no solution is that they have the same slope. So they're parallel lines. Because even if it looks like it's not going to cross, which I won't put that on an exam because I want them like this where they're all in the graph. You could see problems in other courses where they're like, okay, let's say it's off the graph, then you're going to have to make that intuitive thought of, okay, we know this goes all the way this way, and this one goes all the way this way. So eventually, even if it's off the graph, it's going to have to cross. And it's not even showing. Yeah, I did. Okay. But on the exam, I'll make sure they're on the graph. Yeah. Okay. And honestly, once you guys see these notes, and we do the other two notes, it's going to be up to you how you solve linear equations. You could choose the graph, you could choose the substitution method, or you can choose the elimination method. Unless the exam specifically says use this method, you're allowed to use any method. Typically, people don't use the graphing method because of that issue of where it could fall off the graph and you're going to have to make that guess. But substitution and elimination always will give you an accurate answer. Okay. So looking at 15 and 16, notice that one of our equations is already in the correct form. Okay. So that means from there we could already find what is our y-intercept and what is our slope. So we know our y-intercept is 0, 1, and our slope is -2/1. So we don't have to do anything to that green equation. The second equation, it's in standard form, so we're going to have to rewrite it and solve for y. What are we going to do first to solve for y? Subtract the 2x. So I have -y equals -2x plus 3. I don't like that negative in front of the y, so what's going to happen to all the signs? Yep, they're going to change to the opposite because I'm dividing by -1. So it becomes y equals 2x minus 3. The signs all changed, and that was because I divided by -1. So I know from here that my y-intercept is going to be 0, what? -3, and my slope is 2/1. So let me go ahead and plot the first equation's information. So that's 0, 1, and that down to right 1. So that was the green. And then I have my other information of 0, -3. And this one's telling me go up to right 1. And we notice right away it crosses at that point. So that means this has one solution at what point? Good. 1, -1. Okay. On number 16, notice that that first equation has it as x equals. Okay, our equation needs to be set up as y equals. So we're going to have to manipulate that equation to turn it into that y equals mx plus b. So I have x equals 3y minus 6. What should I do first if I want y by itself? think a little bit of the opposite, because now our y is on the right side. We still want to get that y by itself, though. So what would we do first?
Subtract 3y.
So not subtract 3y. We want that y to stay there.
Oh, okay, divide by 3.
That would be our next step. So yes, add 6.
Oh,
So we have x plus 6 equals 3y. Then we would divide everything by 3. So we would be left with 1/3 x plus 2 equals y. Okay, or we could just rewrite this as y equals 1/3 x plus 2. Notice once I have y by itself, I could just put the y on the correct side. It's not going to change the problem. Okay, so that was the first one right here. From here, I know that my y-intercept is what point? 0, nope, we're looking at the new one that I highlighted. 2, yep. And then my slope of 1/3 is telling me to go up 1, right 3. Okay, or I can go down 1, left 3. Okay, so that's my first one. Now I still need to change my second equation to get y by itself. So I have 2x minus y equals 3. What am I going to do to get y by itself? Remember, it's always the x's we deal with first. Subtract that 2x. And so we have negative y equals negative 2x plus 3. So we don't want that negative in front of the y, so what am I going to do to all the signs? Flip them. So I have y equals positive 2x minus 3 now. And that is the pink equation. Sorry, I was trying to zoom in so you could see a little better. So from that y equals 2x minus 3, what is my y-intercept? Yep, 0, negative 3. And my slope is telling me to go up 2, right 1. So I'm going to do that until I cross my other graph, which looks like I cross it at this point here. So that means my answer is what? Yep, 3, 3, 1 solution. Okay, so the only difference between these problems and the problems we did in the beginning is we have to change from standard form to y-intercept form. Okay, let's look at, I'm kind of skipping around a little bit here. Let's look at 23, 24 next. Let me make sure we get all the concepts covered. So now looking at number 23, notice we have one equation that is already in that y equals mx plus b format, and that's that second equation. All we have to do is just make sure y is on the correct side. So here we would just write y equals negative 1/2 x plus 2, because that x has to come first. So that's our new equation in green. Looking at this top equation, it is kind of in standard form, not really, because it does have that negative 4 on the same side as the x and the y. However, we still just need to get it to where y is by itself. So we have 0 equals negative 3x minus 4 minus 2y. We want to move a lot of these numbers over to the other side because we want y by itself. So what are we going to do first?
You add 2y? Not before.
That's a good point. We could just add the 2y over and then we would have y by itself, right? Well, almost. Almost by itself. We could do that way. So 2y is equal to negative 3x minus 4. And then what would we have to do? Divide by 2. So you could do it this way. Okay, or you could have moved the 3x over, moved the 4 over, and divided everything by negative 2. Either way, you just want to get y by itself. Okay, and whichever way that works, you would do that. Whichever way you want to get y by itself. With this way, with moving the y's over first before dividing by that 2, we eliminated a couple steps. So that's good. Okay. So now that I have both my equations in y equals mx plus b form, I'm going to go ahead and start with that green equation. And I'm going to plot my y-intercept, which is at what point?
0, 2.
Correct. And what does that negative 1/2 tell me to do with the slope?
Down 1 over 2 to the right.
Good. Down 1 over 2. Okay, so that is my green equation. Okay. What is my y-intercept for the other equation?
0, negative 2.
Yep, so negative 2. And my slope is telling me to do what?
Down 3 over 2.
Down 3 over 2. So 1, 2, 3. Okay, and I'm also going to go in the opposite direction. Okay, so it looks like it might cross there, but I'm going to go back to my original one where my slope was down 1, right 2, and I'm going to go up 1, left 2, up 1, left 2. Okay, so it is that point there. That was just me verifying my answer, and I have my answer crossing at what point? Negative 4, 4. Okay.
I see why it's important to go the opposite direction.
Correct.
Had we just done the bottom half, I would have said no solutions.
Yeah, and we could tell right away this was going to be a one solution because how the graph of both of them are slowly meeting together. So that was the mistake I did up in the beginning where I didn't continue doing them, and I was like, okay, my point looks a little off. So yes, it's important to do your slope in both directions if your answer isn't obvious, especially when graphing. Okay, so now we're going to look at some that have infinitely many and no solution. So looking at 24, the first step we still have to do is put this in y equals mx plus b form. Okay, so looking at the top equation, we have negative 2x minus y equals 1. How would we get this to have y by itself? Good, add 2x, so negative y is equal to 2x plus 1. And then we have a negative in front of the y, so that tells us what's going to happen to all the signs. Flip them. So this is now y equals negative 2x minus 1. Okay, and that's the pink one that we just solved out. Now we have negative 6x equals 3y plus 3. We want y by itself, so what should we do?
Subtract 3.
Subtract 3 over. So I have negative 6x minus 3 equals 3y. And then what are we doing? We want y by itself, so what's in front of y? Good, we can divide everything by 3. So I get negative 2x minus 1 equals y. But I could write that with y first by just saying y equals negative 2x minus 1. Okay. What do we notice about these equations? They're the same. So if I was to graph these equations, they would be right on top of each other, correct? Because they're the same equation. So I'm going to go ahead and just graph one of them so that you can see. So that negative 2x minus 1 is our y-intercept. And that negative 2 is telling me to go down 2, right 1. Okay. Since our equations are exactly the same, your graphs are just going to look like the lines are on top of each other. So that means in this case, this is how many solutions? No solution or infinitely many?
Infinite.
Good. It's infinitely many because this line crosses the other line multiple times.
The entire time.
Well, yeah, the entire time. So this is infinitely many. And that's all you would write. You're not going to give me points or anything. You would just say infinitely many solutions. And that's because our lines are exactly the same. Okay. Okay, now let's look at 25. Okay, so again, what would be the first step we would have to do in 25? What would be the first step?
Subtract x? No.
Big picture, what's the first step?
Get y by itself.
Good, because in both of these equations, is y by itself? No, so that's our first big picture step. We got to get both equations to where y is by itself. So in the first one, x minus 2y plus 8 equals 0, we would have to do what?
Could add 2y.
Good, we could add 2y over, and that would get our y almost by itself. Or we could subtract the x and subtract the 8 over. Either way, same thing. So that's what I'm going to do. I'm going to subtract the x and subtract the 8. So I get negative 2y equals negative x minus 8. Okay. And you could do it the opposite. You're still going to get the same answer. So then from here, I'm going to divide everything by negative 2. And I get y is equal to 1/2 x plus 4. Then I have the equation negative 6 minus 2y equals negative x. And I have to do the same. I have to get y by itself. So what would I do first?
Add 6.
Add 6. So I get negative 2y is equal to negative x plus 6. And then what would be my last step? Divide by negative 2. So y is equal to 1/2 x minus 3. What do we notice about these two equations?
They're almost the same.
They're almost the same. So they're not exactly the same. So that means it can't be what?
Infinite.
It can't be infinite solution because they are not exactly the same. However, what do you notice about the slopes? The same. So they have the same slope, meaning these lines are going to be what? Parallel or perpendicular?
Parallel.
Parallel. And can parallel lines ever have a solution? No. So we would just say our answer is no solution. Okay. We don't need to graph those because we said that out loud. We said, okay, same slope, parallel lines, so no solution.
If I were a parallel solution, would that be also?
No, it would have to say no solution. You could say no solution because they're parallel lines, but you couldn't say parallel solution. Okay. Okay, now looking at 26. What's our overall big picture step we need to do?
Get y alone.
Get y by itself. So in the first one, we have negative 2y minus 5x equals 2. What do we have to do to get y by itself? Add 5x. So we have negative 2y is equal to 5x plus 2. And then what?
Divided by negative 2.
Divide everything by negative 2. So we have y is equal to negative 5 halves x minus 1. Then we do the next equation. Negative 5x equals 2y minus 4. This is why it's good to do both equations first. Get all the information you need before you graph. So what would we do first to get y by itself?
Add 4.
Good, add 4. So we have negative 5x plus 4 equals 2y. And then what are we doing?
Dividing both sides by 2.
Good, dividing everything by 2. And I'm going to go ahead and put the y on the correct side. So y is equal to negative 5 halves x plus 2. Okay, what do we notice about these equations? Are they exactly the same?
No.
No, so that means it's not going to be what? It's not going to be
One. No.
good. It's not going to be infinite. It's not going to be one solution. Our slopes are the same, so that tells us it's going to be no solution because our lines will be parallel. And you could graph this. You could graph this and see that they are parallel. So let me graph these ones real quick.
So the same slope equals parallel. No solution.
Correct. So this is the green equation, just so if you want a visual. And then if I graph the other equation, notice how they are right next to each other. They're parallel. Okay. Okay. Let's look at 27. Okay. 27 again, we're trying to make sure that all of our equations have y by itself. Okay. So the first equation, we have 2y plus x minus 4 equals 0. So what would we do to get the y's by itself?
Subtract 2y.
Good, we could subtract 2y over, so we would have x minus 4 equals negative 2y. And then what?
Divide by negative 2.
Divide everything by negative 2. And I'm going to go ahead and place my y on the correct side. So I have y is equal to negative 1/2 x plus 2. Okay. So remember, there is that invisible 1 in front of the x. And I just look at the numbers. 1 over negative 2 is the same as saying negative 1/2. Okay, then I have 2y equals negative x plus 4. What would I do to get y by itself? Divide by 2. So I have y is equal to negative 1/2 x plus 2. This tells you right away that this is what?
Parallel, no solution.
Infinite. Why is it infinite and not no solution?
It has the same y intercept too.
Has everything the same. It's the exact same equation, meaning I would have two lines on top of each other. So the answer is infinite solution, or you can write infinitely many. Okay, that's going to be the biggest thing. When I'm asking you to do this on the exam, you're going to have to pay attention. If they are the exact same equation, the answer is infinite. If the slopes are the only thing they have in common, then it's no solution. Yes?
So graphing is not, you don't have to graph.
Unless I tell you to graph. But these are the notes, and the most important thing on the notes is this part right here. Okay. You can always graph to double check your work, and you'll see that both these lines will be on top of each other. Okay. Let's go ahead and look at 28. Okay, 28, our first step is still to get y by itself. So I have -4 equals -2y. What would I have to do to get y by itself? Divide by -2, and I get y is equal to +2. That tells us what? Good. Horizontal line at what point? 2. Horizontal at 0, 2, right? Because I need a point. So in this case, I'm gonna plot it because it doesn't look like it's going to be something where it's infinite and no solution, right? I have an equation here, and it doesn't look like my next equation is going to simplify to y equals 2. Okay? So I'm using that knowledge to determine if I need to graph to see if I'm going to see a solution. So I'm going to go ahead and graph that y equals 2. Okay. Then I'm going to look at my next equation, 4 plus 6x equals -y. What do I need to do to get y by itself?
Flip the signs.
Good. Switch all the signs because I just have a negative there. So I'm going to divide everything by -1, and I get y is equal to -6x minus 4. Remember, when I'm writing this in the correct order, I have to make sure my x's come first. Okay, so right away here, you know it's not going to be infinite. It's not going to be no solution. So that tells us it's going to have a solution. So I'm going to graph that equation, and I would graph first the y-intercept, which would be what number?
0,
Good, 0, -4. And that slope is telling me to do what?
go down 6 and over 1, but you could go up 6 and left 1.
Correct. So if I go down 6, I'm off the graph. So I want to be on the graph. So I'm going to go up 6. And then I'm going to go over to the left 1. Okay, so I see when I draw my line that this connects at 1 point, meaning I have one solution at, good, -1, 2. Okay. And we're going to do one more. We're going to do number 30. So again, first step, because these are not in y equals mx plus b form, is to do what?
Get y alone.
Get y by itself. So I have 2y plus 4 plus 3x equals 0. What would I do to this one?
Or subtract 2, 1.
Good, I could subtract 2y over to the other side, or I could subtract 4 and subtract 3x to the other side. I'm going to go ahead and just subtract 4 and subtract 3x to the other side, so my y stays on the correct side. 2y is equal to -3x minus 4. Why did I place the x first?
That's a good one.
Good, it has to be in that correct format. Now I'm going to divide everything by 2, and I have y is equal to -3/2 x minus 2. Okay, so that's my first one. And then my second one is that negative 2y is equal to 8 plus 3x. What am I going to have to do to everything to get y by itself? Divide by negative 2. So I get y is equal to negative 3 over 2x minus 4. Again, why did I place that x first? Has to be in that format. So now looking at these two equations, this tells you what? Good, they have the same slope, but are they the same equation?
No.
No, so since it's not the same equation, only the same slope, that tells you what type of lines are these?
Parallel.
Parallel, which means I have no solution.